Hi everyone, in today's lesson from Unit 5, we'll be taking a look at another way to measure angles. So far, you've only worked with degrees for measuring angles. Well, there's another unit of measure called a radian. So we're going to learn how to use radian measure, and then you're going to learn how to convert from degrees to radians and from radians to degrees. Right, the main goal is to get you used to working with radian measure. As the further you go in math, the fewer angle measures you'll see in degrees, and you'll see more of them written in terms of radians. Okay, so if we have a circle, we have two radii drawn, right? The distance from the center of the circle to a point on the circle is a radian. When the arc of the circle, right here, is exactly equal to the radius, then we would say that this angle theta is 1 radian. Right, well, let's figure out how many degrees there would be in 1 radian. The circumference of a circle is 2 pi r. If we say that 2 pi r is equal to 360 degrees, and we take and we divide both sides by 2 pi. If you try that on your calculator, just be sure to group 2 pi in the parentheses in the denominator. So we would say that 1 radian works out to be approximately 57 degrees. Okay, so we're going to work with this idea that going from circumference, or the number of degrees in a circle, being 360, to kind of get started on converting some of our familiar angle measures to degrees. So if we complete one full revolution of a circle, that would be 2 pi radians. And we know that one revolution would be 360 degrees. So if we're at 0 degrees, we go all the way around the circle, we go back to 360 degrees. That's equal to 2 pi. Well, what if we just went halfway? If we did half a revolution, half of 2 pi would give us pi radians. 360 divided by 2 would give us 180 degrees. So at 180 degrees, that's equivalent to pi radians. Okay. If we went a quarter of the way around the circle, so 1/4 of a revolution, we would be taking a look at the 2 pi divided by 4, which will give us pi over 2. And we're going to be setting that equal to 360 divided by 4, which is 90. Okay, so a quarter of the way around the circle we know is 90 degrees, and that would be equivalent to pi over 2. Again, because it's halfway between 0 and pi radians. Well, 3/4 of the way around the circle, 3/4 of a revolution, if we do 3/4 times 2 pi, that would be equivalent to 6 pi over 4, which reduces to 3 pi over 2, and that would put us at 270 degrees. So 270 degrees is equivalent to 3 pi over 2 radians. All right, so we have our first few, okay? There are some that are commonly used, and so you want to get to know these. You want to have these kind of in your knowledge bank, okay? And these refer back to our special right triangles. So they're 30, 60, 90, and 45, 45, 90. We want to start to get to know those angles of 30 degrees, 60 degrees, and 45 degrees in terms of radians. Okay, So again, if we start with pi being equal to 180, we learned that if we divide by 2, we get pi over 2 is 90 degrees. Okay, so that's one that we should know. If we did pi over 3, that would be 180 over 3, which is 60 degrees. So this is another one we should know. If we did pi divided by 4, that would be 180 divided by 4, or 45 degrees. And then if we did pi over 6, that would be 180 divided by 6, which is 30 degrees. Okay, so if we get to know these facts, again, it's going to help you out. Okay, as I mentioned, angle measures of 30, 45, 60, and 90 are commonly used in trig to get exact value answers, and we want to get used to seeing them in radians. So what we're going to do is set up a bunch of unit circles with their measures right on there for you. We'll teach you how to count by each of these special angles as we go around the circle. Always coming back to the fact that pi radians is 180 degrees and 2 pi radians would be equal to 360 degrees. Okay, so remember those two facts. So in the first circle, we're just going to go back and review what we did before. So this would be 0 degrees. 1 complete revolution, we would be back to 360. So that would be 2 pi. If we just do a quarter turn, that would be 90 degrees. 1/4 of 360 is 90. Remember that would be pi over 2. Well, if you want to count by pi over 2's, this one would be 2 pi over 2, because that's 2 times 90, but notice that that reduces to pi. So 180 degrees is equal to pi. If we keep up with a pattern of counting by 2 pi over, by pi over 2, we have 1 pi over 2, 2 pi over 2, we would get 3 pi over 2 next, and that's equivalent to 270 degrees. And then we would finish it off again with 4 pi over 2, which reduces to 2 pi. Okay, so we're counting by pi over 2 each time. In the next circle, we're going to be counting by 45 degrees. So let's put the degrees on there first. 0, halfway to 90 would be 45, then 90, add 45 to that, and we're going to end up with 135. Add 45, we're at 180, 225, 270, 315, and 360. Okay, converting these into radians. So 45 degrees is 1/4 of the way to 180, so it's pi over 4. 90 would be 2 pi over 4, but remember we want to reduce that to pi over 2. 135 would be 3 pi over 4. 180 would be 4 pi over 4. That reduces to pi. 225 is equal to 5 pi over 4. 270 would be 6 pi over 4, which reduces to 3 pi over 2, so we reduce where we can. 315 would be 7 pi over 4. And 360 would be 8 pi over 4, and we know that as 2 pi. So you're adding pi over 4 every single time. Okay, 2 down, 2 to go. The next one, we're going to work with 60 degrees, and I should have deleted the y-axis in here. We're going to ignore those 2 points. So we're going 0. If we add 60, we're here. 60 plus 60 is 120, so we're going to be skipping over 90. 120 plus 60 is 180. 180 plus 60 is 240. 240 plus 60 is 300. Okay, so 60 degrees in radians is equal to pi over 3. And I wrote pi over 6. So pi over 3, let's get that in there. All right, so this will be 1 pi over 3. That's 1 times 60. So 1 pi over 3. 120 would be 2 pi over 3. 180 is 3 pi over 3, which is just pi when we reduce it. Add another pi over 3. 240 is 4 pi over 3. 300 would be equal to 5 pi over 3. And 360 would be equal to 6 pi over 3. And again, it reduces to 2 pi. So that's counting by 60 degrees. We add pi over 3 each time. And the last one, the smallest angle, 30 degrees. We're going to go 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and back around to 360. Okay, so I just added 30 degrees each time. 30 degrees in radians is equivalent to pi over 6. So we're going to be adding pi over 6 each time. So 30 pi over 6 for radians. 60 would be 2 pi over 6. We're going to come back and reduce that in a second. 90 would be 3 pi over 6. 120 is 4 pi over 6. 150 is 5 pi over 6. 180 is 6 pi over 6. 210 is 7 pi over 6. 240 is 8 pi over 6. 270 is 9 pi over 6. 300 is 10 pi over 6. 330 is 11 pi over 6. And finally, 360 is 12 pi over 6. So on this one, I decided to do the counting first, but we can go back and reduce. So 2 pi over 6 for 60 degrees would reduce, of course, to pi over 3. For 90, 3 pi over 6 reduces to pi over 2. For 120, 4 pi over 6 reduces to 2 pi over 3. 150 is going to stay at 5 pi over 6. We know 180 is equivalent to pi radians. 210 is going to stay at 7 pi over 6. 240, 8 pi over 6 would reduce to 4 pi over 3, because these angles that are reducing, that are not quadrant angles, they're multiples of 60 as well. 270, we know this one is 3 pi over 2. 300 is going to be 5 pi over 3. 330 is 11 pi over 6, that's going to stay. And 360, we know is 2 pi. All right, our next skill is converting from degrees to radians, and you just need to remember that you're going to multiply by pi over 180. So we're going to take 240 degrees, put it over 1, and multiply by pi over 180. Now, you could reduce here, or you could write it as 240 pi over 180 first. And what you want to do is divide out common factors. You don't want to jump to your calculator and get a decimal. That would be inappropriate. You're going to have an answer in terms of pi. So 240 and 180 are both divisible by 60, and that's going to leave us with 4 pi over 3. And if you think about it, 240 degrees is a multiple of 60. Pi over 3 is the radian measure for 60 degrees. 4 times 60 is 240. Okay, negative 270, getting converted to radians. You might be able to do it without writing the fraction if you think about what you know about positive 270 degrees. So we have negative 270 times pi over 180 for the conversion. And I'm just going to go ahead and reduce it and divide by 90. So we get negative 3 pi over 2. Right. If we're converting from radians to degrees, we multiply by the reciprocal, 180 over pi. So we're going to take negative 11 pi over 6, and we're going to multiply it by 180 over pi. Those pi's would divide out, and then 6 goes into 180 30 times. So we have to take negative 11 times 30, which will give us negative 330 degrees. Until you really get used to working with radian measure, you may want to convert your angles to degrees, just to help you make sense of what the angle looks like when graphed. Negative 7 pi over 6, we're going to multiply it by 180 over pi. Pi is divided. 6 goes into 180 30 times. Negative 7 times 30 is negative 210. Okay, so here's where converting to degrees may help you. If you're not sure what 5 pi over 4 will look like when we try to sketch the angle, then convert it to degrees first, and then find the reference angle in degrees, but also convert it to radians, okay? So 5 pi over 4, converting it, multiply by 180 over pi. The pi's would divide out, and 4 goes into 180 45 times. So we would have 5 times 45, which is going to give us 225 degrees. Now, if you want to use your chart on the previous page to see that 5 pi over 4 is 225 degrees, that's fine too. All right, initial side of the angle on the positive x-axis, rotate 225 degrees. We're down here in quadrant 3. Okay, so this would be 5 pi over 4 for our angle. If we want to get the reference angle, we're looking at this angle here, because we always measure back to the closest x-axis, and that would be 45 degrees, or pi over 4. All right, we want it both in degrees and in radians, please. Okay, notice that your fraction had a denominator of 4, so pi over 4 is 45 degrees, so I want you to start to know that if it's pi over 4, it's a multiple of 45. Your reference angle will be 45 degrees. All right, 2 pi over 3. Again, you can do the conversion this way, multiply by 180 over pi, and it's going to give us 120 degrees when we reduce. But notice that denominator is 3. Pi over 3 is equal to 60 degrees, so I know that this is a multiple of 60. Okay, 120 is going to put us into quadrant 2. All right, so that's 2 pi over 3, or 120 degrees. Our reference angle in this particular case would be 60, because we have 60 more degrees to go through to get to 180. So we'll say reference angle equals 60 degrees, and remember to convert it to radians, and it would be pi over 3. But again, I kind of knew that reference angle from the beginning because I noticed that my denominator was a 3. All right, 15 pi over 4 is equivalent to 675 degrees when you convert it. All right, and that would be equal to 360 plus 315 more degrees. So we've got a complete rotation. All right, so one loop around and then 315 more degrees to put us into quadrant 4. All right, so if we're at 315 degrees and we're measuring to the closest x-axis here, we have to go through 45 more degrees. So our reference angle would be 45. And remember that that's equal to pi over 4 in radians. So I have to have both the angle measured in degrees and radians. And again, look at your denominator to start. It's 15 times pi over 4, so it's 15 times 45. Our reference angle is going to be 45. Now, D is a little different. We can't use that logic. 12 as the denominator doesn't really help us out. This is not going to be one of our angles that we've seen used commonly. So convert it, right? Divide out those pi's. 12 goes into 180. We're going to end up with 195 degrees. And when I graph that one, it's going to put us into quadrant 3. All right, so 195 degrees, or a reference angle, or an angle of 13 pi over 12. And if I measure back to the x-axis right there, this angle is going to be 15 degrees. All right, so you got a reference angle, a little bit unfamiliar. We haven't seen anything other than the standard angles that we used on the previous page. Convert that 15 degrees back to radians, and it would be equal to pi over 12, 1 pi over 12. And again, you're converting it back by taking 15 and multiplying by pi over 180. All right, negative 11 pi over 3, if I convert it, 180 over pi, it's going to be negative 11 times 60, or negative 660. So that would be a rotation of 360 degrees, negative 360 degrees, plus 300 more. So don't forget, if it's a negative rotation, negative angle, we want to start on that positive x-axis as always, but we're going to go in the clockwise direction. So that's 360, another 90, 180, 270, 300 would put us into quadrant 1. Now be careful in this one when you go to find the reference angle. Remind yourself that you want to go to the positive x-axis, so the reference angle would be in here. So if this angle, if we stopped here in the first quadrant and we went 300 degrees to get there, then we have 60 more degrees to get through to get to that positive x-axis. So our reference angle would be 60, or pi over 3. And again, we're back to one of our angles that we said was going to come up very often. Denominator being 3 tells me that this is related to 60 degrees. Okay, 3 pi over 2, a little bit of a surprise at the end here. 3 pi over 2 is just 270 degrees. It's a quadrant angle, so we would just say that we're on the negative y-axis. Okay, and that's it for that one. All right, for coterminal angles, we are going to add or subtract 2 pi. We're going to try to keep these in terms of radians, so no converting to degrees and then back to radians. We're going to try to save time because we're doing adding and subtracting 360 degrees essentially. So 360 degrees is 2 pi. If we want to find one positive angle that's coterminal with pi over 4, we're going to add 2 pi. If we want to find one angle that's coterminal with 7 pi over 4, but we want a negative angle, we're going to subtract 2 pi. What we need to do is have a common denominator. Which in this case would be 4, so multiply numerator and denominator by 4. And we end up with 7 pi over 4 plus 8 pi over 4, because we multiply top and bottom by 4, and that would give us 15 pi over 4. Okay, we can save a little bit of time here. We've already found the LCD of 4, so take 7 pi over 4 minus that 8 pi over 4. because that's equivalent to 2 pi. And 7 pi over 4 minus 8 pi over 4 is negative 1 pi over 4. Or you could just write minus pi over 4. You don't need the 1 in there. Okay, with 5 pi over 12, again, to find a positive angle coterminal with it, add 2 pi. To find a negative angle coterminal with it, subtract 2 pi. Find that common denominator first. We need an LCD of 12, so multiply by 12 over 12. So you have 5 pi over 12 minus 24 pi over 12. And that would give us negative 19 pi over 12. Okay. In here, sorry, we're adding, so this would be positive, and it's going to be 29 pi over 12. All right, down here, again, we already know what this is in terms of twelfths, 24 pi over 12. So we're going to take 5 pi over 12 minus that 24 pi over 12. And now we get our negative 19 pi over 12. Okay, so that's a 1 sneaking in there. Let me fix it. Negative 19 pi over 12 for our negative angle that's coterminal with that original one. All right, as always, if you need help, please send me an email or come and see me after school for extra help.